measure and sine and cosine curves. Well, actually, we'll start with sine and cosine for curves, and then we'll talk about the radian measure. So my goal is for you to be able to do that. So we'll just review with a few concepts. The unit circle and their signs. Okay, so I'm going to try and be neat, and you be as neat as well on your own file. Neatness is important with this. Okay, when you draw yourself a nice, beautiful unit circle, hopefully yours looks better than mine. If you remember, these coordinates are for a unit circle. I always get like the numbers, the 1 and the 0 mixed up, so I used to just say negative 10, 10, and then I go back and I put little commas in there. So a little comma, there we go, parentheses. This is, because these are coordinates, right? And then up here, well, that would be the coordinate 0, 1, and this is the coordinate 0, negative 1. And remember, these are coordinates because this is a unit circle, so this is 1, negative 1, 1, negative 1. Okay, so if you also remember, there was a way to remember that you have the x coordinate and the y coordinate. If you remember, what is always the x coordinate and the y coordinate? Some people remember in order, alphabetical order, or you can remember the little, I don't know why I think of the game, Counter-Strike. So yeah, the sine is the y coordinate because this is x and y, right? So this is 0. And, oops, sorry, I meant sine, and this would be cosine. Oops, sorry. Okay, anyway, that's, you know, one thing there, and I just wanted to review that and review these pieces. Now, the other thing I want to review is about the angles. So when we talk about the angles, we talk about this being 0 degrees, this being 90 degrees. Over here, this would be 180 degrees. This one down here, between the third and fourth, 270 degrees. And back to the beginning, this would be back to 360 degrees. Okay. And if you remember, the quadrants are, all of them are positive in the first quadrant. Second quadrant, only sine and its roommate cosecant. This one, only tangent and its roommate cotan. And this one would be only cosine and its roommate secant. Right? So that's their little rooms. That's where they're positive, negative. A helpful way to remember that is that everything in this quadrant is positive, positive. This one's negative, positive. This one's negative, negative. And these are positive, negative. Okay? Whatever works for you. Okay. I just wanted to review that. Now let's get into the graphs. Okay. In order to do that, we're going to look at theta and we're going to figure out what the sine of theta. Now we're going to use, now you can type this in your calculator, but I mean, you have this right in front of you, the unit circle. So you can just look at the unit circle. And when you look at the unit circle, you would see that, oops, never mind. So at 0 degrees, all right, I'm going to use the quadrants. So I'm focusing on sine here. So that is my x value, remember? That looks ridiculous. So I'm just gonna, yep, that's my x value. My y value, yikes, that's my y value. So that would be here. So at 0, it is 0. And I'm gonna keep going around at all the y values at all the different degrees and put them in. What is it at 90? 1. What is it at 180? 0. What is it at 270? Negative 1. What is it at 360? 0. And if I was to keep going with this, the pattern would repeat. It would be 0, 1, 0, negative 1, 0, 1, 0, and it just keeps going over and over again. It makes me think of a bicycle as it turns, the wheels go turning and the height keeps changing. I mean, that's pretty much what is happening there. And now what you're going to do is you're going to take that information and you are going to graph it. Sounds a little weird, but all sine and cosine curves have this repetition, this pattern that it repeats, and it's used a lot in real life because we have the tidal waves, the tides change, the temperatures change. In life, it happens all the time, like the bicycle, whatever. So I'm going to start here at 0, and I'm going to ask you to break this up. See, from 0 to 360, that after you put that first one, that you always put 4 more, because we have 4 quadrants. So we're going to have 4 sections. So there's 1 section here, 2, equal length, 3, 4. And those are like literally my quadrants, like quadrant 1, 2, 3, 4, right? So for this first dash, label it nicely. That one is going to be, so here we started 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. Okay, and that would be going the other way as well. Okay, so I will go negative 90 degrees, nice and neat, negative 180 degrees, negative 270 degrees, negative 360 degrees. Okay, and you're going to use a different color to make it look nice. And this is as high as it's going as high as 1, and it's going as low as negative 1. Do you see it go any further than that? No. Okay, so I start at 0, it goes 0, then it goes up, then it goes 0, and then it goes down, and then it goes back to 0. And it does not look like some pointy weird thing that you're thinking of. It looks nice and curvy, beautiful, like nature, because math is nature, right? So I remember it as, and again, don't make fun of me, but I remember like a little song, like O, max, O, min, O. It starts and ends the same, okay? O, maxo, minno, maxo, minno, and it repeats its little process. It keeps going, okay? If I was to keep going, it would just keep doing do, 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 O, maxo, minno, okay? But we're not going to do that. So, and this can go the other way. Wait a minute, negative 90 degrees. What the heck? That means, if I go back to my unit circle, that means I'm going from 0, I'm going negative 90. See what I'm saying? I'm going this way. And you see it goes down to negative 1. So I'm going to plot that. So it continues the O max, O minno, just the other way. So it goes, but it goes O, min, O, max, O. Bam. You're done. Moving on. That's your sine curve. I know it's a sine curve because it starts with O and ends with O. Oh, sine, O, sine, O. Sine, O is O, max, O, min, O, whatever. Remember it. Let's move on. All right, now we're going to do cosine. That's right. We got to find out what those numbers are. You might be like, we got to go back and see that other picture. Well, you can if you want to. Or you can just be like negative 10, 10. Don't be lazy. Just draw this. 0, 1. 0, negative 1. You know that cosine are the x values, right? So I'm going to pick a different highlighter, this one. So you know that, oh no, that's way too light. For sure. I'll do this one. Okay, it's the same one as before, wasn't it? So that's your x values, remember? So that's like x, these are all the x values, right? But of course, I got to start at 0, and 0 starts me right here. That's 0 degrees. You know that. And then you just go around. So at 0, it's 1. That's a 1. At 90, what is it? That's right, 0. At 180, what is it? Negative 1. At 270, what is it? That's right, you're looking there. You're thinking, oh, that's 270. 0. And then 360, it's back to 1 again. It starts and ends the same. Every sine and cosine curve, every type of curve like that start, and they're called sinusoidal, okay? There's a repetition that happens, repetitions that happen in nature, and we use these for that reason, okay? So I'm going to make this nice and neat. This is 0. Break it into even pieces. There's 4 quadrants here. So this is one space. That's 90 degrees. 180 degrees, 270 degrees, 360 degrees. Okay, make it look nice the other way. 90 minus 180 minus 270 minus 360. Okay, so now I'm going to plot this. It goes from -1 to 1. And this time, no, it is not like sine. Oh, sine. Oh, sine likes to start at O, but not cosine. Cosine likes to start up here at the top or at the bottom. It likes, in this case, it's the top. So it goes max, and it goes down here to 0. And after that, it's got to hit bottom, then go back to the middle and back to the top. So it looks like that. Nice and curvy. Anything pointy, just undo it and do it over. Going backwards. If you were going backwards this way, -90 degrees, that is 270 is the same as -90, right? So that goes, remember it's the x value, so it goes to 0 here, back. Now, I told you, and this, you don't make it look like it's going to keep going up. Make it look like it's going to go back down again, because that's what it does. And just remember that this time, sorry, I had to let my cat out. This time, it is not O max, O min, O. It's max, O min, O max. It always has an O. I said my O. Okay, so it always starts and ends the same, and it always has an O in between. I almost missed mine. Sorry. So max, O min, O max. Okay. Let's examine it some more. Now that you don't go back, try not to look at it. Try and draw the nice, neat curve. Look at me with my little lines trying to make them look nice. So sorry, I couldn't make it work, but whatever. So we're just going to do one side. 0, 90. You know what? I'm going to do that at the end. Just do the curve first. So it's sine. So it starts with O. Then it's going to go to max. It's going to go O. It's going to go to min. It's going to go to O. O, max, O, min, O. Right? So max, O, min, O. That's how the curve looks, okay? You can have the 90 there. You can say this is the end of the whole thing, 360. You want to label each one? You can. You don't have to, okay? I really just need at least one of them. I usually prefer the first and the last, okay? Let's look at cosine. Cosine, does that start at O? That's right. It starts at max, at 1. So it's max, O, min, O, max. Okay, I'll make that 0. I'll make that 360. What the heck? Oops, this is 180. This is 270. This is 90. Okay, all right, and these are all degrees. Okay, now I want to take a moment, because math is just so beautiful, and I know you don't always want to admit it. Oh, what did I do? What the? Oh, I went to the wrong thing. I'm going to have to fix this later. Okay. Now let's talk about how beautiful math is. So I am going to grab this and point out that right here, this is my first quadrant. Remember me telling you that? And this is the first quadrant here. Okay? And I might as well show you all of them. These are the different quadrants. I'm just going to mark them all for you. Here's the second quadrant. Here's the second quadrant. And I see the quadrants are, 0 to 90, 90 to 180. And now 180 to 270, 180 to 270. I know these are all supposed to be the same size. Don't make fun of me, okay? Listen, I'm not perfect, okay? Let's see, I get a little, yeah, purpley. Okay, and here are the quadrants. Now, just examine real quick, right? In quadrant 1, quadrant 2, quadrant 3, quadrant 4, right? When you look at these quadrants, and if you remember the A, S, T, C, you tell me, okay, are all, well, we don't have tangent here right now, but both of these are positive in the first quadrant. See that in the blue? That's the first quadrant. They're both above the x-axis. Now look at the second quadrant. In the second quadrant, only sine is above. That's the only one above. And look, you'll see cosine is below. And when we do tangent, you'll see that later. Tangent, both sine and cosine are negative. See that? Sine negative and cosine negative. That's right. They're both negative. And then the fourth quadrant, who is the only one? Do you see sine? Sine's negative. But cosine? Well, cosine is positive. Okay? So that is why we do these ASTC, because it also kind of goes with these curves. Okay? So, moving on. Last thing I need to talk to you about are the angles. Okay, it's really nice. We do 0, 360, 90 degrees, all these beautiful things. But unfortunately, radians are really preferred when using, with graphing. Radians are preferred. It is because of reasons of higher math. 360 degrees, I mean, listen, it kind of works, okay? There's a whole thing about it, but I'm just going to have to let you know that you need to know about radians. So here you go. In calculus, I teach calculus. There's never anything in degrees. Everything's in radians. So let's get started with that. So all you really need to know here is, just like there are 12 inches in a foot, there are 180 degrees in pi radians. That's right, 180 in pi radians. Pi is about 3.14. So there are 180 degrees in about 3.14 radians, okay? So let's do a little conversion here. The conversion is to put these, when you see 0 degrees, and you guessed it, that's going to be 0 radians. And that's not going to have a degree symbols. That's just radians. We can abbreviate that with rad. We just said it over and over again. 180 degrees is equal to pi radians. So you see where you see 180? Yep, that's pi radians. Now you can do a little conversions. You want radians multiplied by pi over 180, and I'll show you how to do that. But you can also use a little common sense. 180 degrees and 90 degrees. Well, 90 is half of 180. So what you thinking 90 is going to be here in radians? That's right. It's half of pi. All right, it gets a little tricky for 270, and I'll show you that one. But 360, if 180 is pi, then what's 360? 2 pi radians. You don't have to keep writing radians. I'm just doing that right now. But 270, some people get a little freaked out by that one. They're not sure. If you figured it out, great. It's really just 270, and then you just multiply by pi over 180. And what you'll notice is 270 and 180 reduce. The fraction reduce. If you were to just take your calculator or work it out, 270, 180, that reduces to 3 over 2. So this is 3 pi over 2 radians. Okay, so the whole multiplying by pi over 180 could have always happened. Like if you have 90 degrees here, you can multiply it by pi over 180. That says 80. And if you reduce that, that's 90 over 180 pi, which is just a half, pi over 2. So same thing, or a half of pi. All right, so now let's create the unit circle using radians. So I'm just going to go with I'm just going to do this. This used to be 0 degrees, but now we're going to call it 0 radians. What's this one going to be? That's right, pi over 2. This one's going to be pi, and this here is going to be 3 pi over 2. That's all it is. And so when you do your angles, the coordinates, remember, just don't mess it up. So write -10, put a comma between them, and then to the right, you write 10, and then put a comma. And this is 0, 1. This is 0, -1. All right, so I'm going to graph the sine and cosine curve, but this time we're not going to be writing degrees. So I know sine curve, I love it. Sine starts with O, sine. O, sine. O, max. O, min. O. But this time you write 0, and then you don't write 90 degrees. You write pi over 2. You got it. This one's going to be pi. 3 pi over 2. 2 pi. Cosine's term. Cosine. Cosine. Cosine starts with max. Max. O. Min. O. Max. They start and end the same. They have to start and end the same. Don't you forget it. This is 2 pi. 1 full cycle is 2 pi. Pi. 3 pi over 2. Pi over 2. That does look much nicer when it's in radians because, oh, I messed up. I need to put a 1 here and a -1. Bad woman. But I heard you telling me. 1, -1. There you go. Now we're good. Okay. Now, just to do some of the conversions, I told you I'd get back to it, and then this is the end of it, okay? So, convert to radians. All right. My little pointer here that I would tell you, it just some way to just remember it, is that it's called a conversion tip. You know, the unit you want goes on top. So what you want goes on top. So whatever unit you want, that's the one that goes on top, and that's what you multiply with. You multiply with whatever it is. So I just keep that in mind when I do these. So in other words, I have 30 degrees and I'm like, oh, I got to change it to radians, and you can try and figure it out and whatever. But the easiest way to do this, to convert to radians, is I want radians. So I multiply by pi because I know pi is equal to 180, right? So pi over 180. And then what I do is I reduce that fraction. So then this is like, when I reduce the fraction, so on the side, that's like 30 over 180, right? And you go 30 over 180, simplify that, put in your calculator, whatever the heck you want to do. Yep, you thought it right. That's 1 over 6. So this is 1 over 6 pi, or you can say pi over 6 just to be all neat and fancy, okay? So this one, 45 degrees. All right, what I want is radians, so pi radians. What? I did not just do that. Okay, so pi radians over 180 degrees. Simplify that. So I end the side in my mind. I go, well, what's 45 divided by 180? And simplify that fraction. You got it. 1/4 pi. 1/4 pi, or I'm just going to say pi over 4. Same thing. Just looks neater this way. All right. Next one, I want radians, so pi radians over 180 degrees. 60 over 180 is equal to pi over 3. All right, nice work. Let's move on. Now, if we have to go the other way, degrees, if you just keep in mind what I say, what you want goes on top. So I want degrees because it says convert to degrees. So I'm going to multiply by 180 over pi. All right. And what's going to nicely happen, which often does, those little cutie pies, they cancel out. So then this is 3/4 times 180. So you can put that in your calculator. I prefer you do like 180 divided by 4 first and then multiply by 3. But it doesn't matter how you do it. So it's 3 over 4 times 180, so that is 135 degrees. What quadrant is that in? That's right, the second quadrant. Okay, I didn't ask, it's okay. All right, what about this one? I gotta convert to degrees. So what I want is degrees, so it's 180 over pi. I multiply it. The little pi's cancel out. Woohoo, so it's 5 over 6 times 180. I'm just like working that out right there. And what's that going to be? Well, when I divide it by 6, it's, when I divide it by 6, it's 30, so it's 150 degrees. Now this one, it says convert to degrees. So you're like, oh yeah, I want to multiply it by 180 over pi. And you're like, but the pi's didn't cancel this time. Ooh, that's kind of annoying. So don't worry about it. Just this time, you literally have to take it and type it in your calculator. So it's 3 times 180 divided by, and you put the pi symbol in your calculator. That is 171.887 degrees, and that keeps going, right? Now does that make sense? Does that really? We did say 3.14 is 180 degrees, right? So 3, well, being 171 degrees, yeah, that makes sense because 3.14 is 180, and that one's almost, 3 is a little less than that, so 170 is a little less than 180. All right, last one. The special right triangles. Always love to review this stuff, right? Don't you? I know, you're just as excited as me. Hold on with your excitement. Let's do this. The special right triangles are these beautiful right triangles that we talked about. Okay? Well, anyway. So you remember this was 30 degrees usually, and this is 60 degrees. These are both 2. This is 45 degrees, 45 degrees. And then it's, what's next to 30? Rad 3. What's opposite that 30? 1. Here, what are these two? These same ones. If you've been paying attention, you would know those are both rad 2. But wait a minute, I said to do it with radians. Oh, duh. That means I'm going to have to erase this. Not 30 degrees, not 60 degrees. I want to write that as radians. So what do I write that as? 30 degrees is the same as pi over 6. I just remember it like this. I know I should compute it, but I know that 30 degrees is pi. I just remember like the 3 and the 6. I don't know. Anyway, and then this one is pi over 3 because 60 degrees is pi over 3. What's 45 degrees? Pi over 4. So I'm going to erase these and put pi over 4 in both of them. Okay, there we go. I just wanted to review that. All right, lastly, this is the end. This is our conclusion. Which curve is the sine curve and which one is the cosine curve? And one's given a little more information than the other. All right. So, you remember, what does sine like to start with? You said it likes to start with O, and then it goes O max, O minno. That would be your sine curve. Okay? The cosine curve starts with a max, and then it ends in a max. Or it could start with a min and end in a min, which we'll be doing later in the unit. So this is cosine. This is just a way to remember it. If you want degrees, you multiply by pi over 180. If you want radians, you multiply it by that one. Okay? All right. Lastly, just have to mention it. Why degrees? There's a lot. You can look it up and stuff. But basically, degrees, the way you